For us to find the first three terms in ascending power of x of the binomial expansion of this. And we must first write it as 4 minus x to the minus a half, not do a binomial expansion of just the denominator. Okay, here is our general formula. So 4 minus x to the minus a half. It's not quite in the right form at the moment. We first of all need to factorize out that 4, like so. And it's all of this that's being raised to the power of minus a half, which gives us 4 to the minus a half multiplied by 1 minus x over 4 to the minus a half, which actually becomes a half times 1 minus x over 4 to the minus a half. Right, we're ready to go. So our n is actually minus a half, and our x is actually minus x over 4. So just replace these in the formula on the expression on the right, and we're there. So I'll just put the half outside. Sometimes I bring it back in at the end, but I don't want to forget about it. And it's not like too much. So it's only 3 terms. 1 plus nx. So it will be plus minus a half times minus x over 4 plus minus a half times n minus 1. That becomes minus 3 over 2 all over 2 times minus x over 4 squared. Then bracket. Okay, I'll deal with the inside part first. So we'll get a positive here. It'll be x over 8. Now this is a little bit more complicated. It is probably, yeah, it's best to put it in your calculator. You know, you can try and do it by hand. There's lots of divisions going on. You can just times 2 by 2 by 2, 8, and then times by 16. That actually gives 128. There's like 4 negatives, which becomes positive. It's going to become 3 over 128. But, you know, absolutely fine to just take it steady and do it by hand. I am going to get rid of the negatives because we can see that they cancel, but by all means put them in. 3 over 2 is 1.5. Okay, so that's that first bit. And then times by 1 over 4 squared to get the x part, 3 over 128. Which gives me a half plus, I'll write it as a fraction in front of it, so 1 over 16x plus 3 over 256x squared. That is our binomial expansion for this function. Well, this question then actually goes on to approximations using binomial expansions. It doesn't ask us to approximate, it just tests us on our understanding of it. So it's then we could put in some different values of x, which would lead to the expression on the left being in terms of root 2. So if we wanted to find an approximation for root 2, we could potentially substitute any of those values in without evaluating our expansion, which should not be used. Okay, it all comes down to this thing here, the modulus of x being less than 1. Now actually, Rx, remember, is not x, but minus x over 4. So our expansion is valid for the modulus of x over 4. You can ignore the negative, the modulus of x over 4 being less than 1, which means the modulus of x is actually less than 4, or x is between minus 4 and 4. Okay, well, 2 are absolutely fine. It's this one that's not. So our answer to part 1 is going to be x equals minus 14. Should not be used. Because what would actually happen in this case is the terms wouldn't go to 0. That's, you know, that's a requirement for our expansion. I'm just going to say since minus 14 is outside of the valid range. Okay, just some words along those lines. And then which of the three, okay, we've already said that one's not okay, but which out of these two would lead to the most accurate approximation? It's going to be this one, because the smaller your x is, the quicker the terms are going to go to zero. And so we're going to need less of them to get a good approximation. So x equals minus a half will lead. Now the answers say since it is closest to zero. So I do like that. I actually wrote down that the terms will converge to zero more quickly. Okay, both of those are okay. Um, so yeah, that is that question done. Well done.